Hi learners, welcome back to Dilk. So in this video we are going to cover the complete first chapter of class 10 CBSE chemistry, which is chemical reactions and equations. So this is going to be one shot video, meaning we will go through the entire chapter from start to finish all in one go. So make sure you are comfortable and let us get started. So alright, so let's begin. The very first thing you need to understand what is a chemical reaction. What do you mean by a chemical reaction? So in our daily life we see so many things happening around us. Iron gets rusted, milk becomes sour, a piece of paper burns and turned to ash. All of these things that are happening, all of these are a chemical reactions. So what is a chemical reaction? A chemical reaction is basically a process in which one or more substance, which we call reactants, get transformed into one or more new substance, which we call products. The substance that take part in the reaction are called reactants, and the new substance that are formed are called products. Now the next question is that how do we know a reaction has taken place? So there are some signs or indicators that tell us a reaction has happened. First one is a change in color. For example, when you burn a magnesium ribbon, you see a dazzling white flame, and the grey ribbon turns into white powder. The color has changed, so a reaction has happened. So like that, the iron turns to reddish brown when it rusts. There is a color change. So reaction happened. Now the second indicator is evolution of gas. For example, when you add zinc to sulfuric acid, you see bubbles of hydrogen gas being released. That gas is a sign of chemical reaction. And third is the formation of a precipitate. A precipitate is an insoluble salt that forms suddenly when two liquids are mixed. For example, when you mix sodium sulfate solution with barium chloride solution, a white solid suddenly appears at the bottom. That white solid is called a precipitate. It tells you a reaction has taken place. Fourth is a change in temperature. If a reaction releases heat, the container becomes warm. If it absorbs heat, the container becomes cold. Both these tells us a reaction is going on. And fifth is a change in smell. For example, when food gets spoiled or oil becomes rancid, it starts smelling bad. That change in smell is also a sign of chemical reaction. So these are the 6 different examples for the signs of chemical reactions. Now let me give you some very simple everyday examples so you can remember this easily. Milk souring in summer. An iron nail turning rusty when left in a humid place. And grapes of fermenting and turning into wine. Food being digested in your body during respiration. And a magnesium ribbon burning with a bright white flame. All of these are chemical reactions you can see or experience in real life. Got it? Now let us move on to the next topic, which is chemical equations. So once we understand that a chemical reaction is happening, we need a way to represent it on a paper. We do this using chemical equations. The simplest form is called a word equation. A word equation uses the names of the substance. For example, magnesium reacts with oxygen to give magnesium oxide. That is a word equation. But in chemistry, we use a more precise and scientific way of writing it using chemical symbols and formula. This is called chemical equation. So for example, 2 magnesium plus O2 gives MgO, 2 MgO. Here magnesium is a symbol for magnesium. Oxygen 2 is the formula for the oxygen gas. This is O2 molecule. And MgO is the formula for magnesium oxide. Now in a chemical equation, the substance on the left side of the arrow are called reactants. These are reactants. The arrow, what does it mean by this arrow? This arrow itself means reacts to give, or it means yields. And the substance on the right side of this arrow is called products. If there are 2 or more reactants, they are separated by a plus sign. Similarly, if there are 2 or more products, they are also separated by a plus sign. Now, there is something very important. There are 2 types of equations. One is called a skeletal equation and the other one is called balanced equation. A skeletal equation is one where we just write the chemical formula of the reactant and products, but we do not check if the number of atoms is equal on both sides. For example, Mg plus O2 gives MgO. This is skeletal equation. It looks fine, but it's actually wrong because the atoms are not balanced. On the left side, we have 2 oxygen atoms, but in the right side, we have only 1 oxygen atoms. The number of magnesium atoms are same, but you can see the number of oxygen atoms are not balanced. So the atoms are not equal. So a balanced equation is one where the number of atoms of each element is exactly equal on both sides. That is balanced equation. A balanced equation is one where the number of atoms on each side of the arrow mark, they are equal. The correct balanced equation is 2mg plus O2 gives 2mgO. Now if you count on the left side, there are 2 magnesium atoms and 2 oxygen atoms, and the right side there are also 2 magnesium atoms and 2 oxygen atoms. The atoms are balanced. This is balanced chemical equation. So now the question is, why do we need to balance equations? This brings us to very important law in chemistry. It is called the law of conservation of mass. This law was stated by a scientist named Anthony Lavoisier, and it says that mass can neither be created nor be destroyed in a chemical reaction. That is law of conservation of mass. Mass can neither be created nor be destroyed in a chemical reaction, and the total mass of the reactant is equal to total mass of the product. Therefore, we can say the number of atoms of each element must be equal on both sides. The number of atoms of each element on this left side must always be equal to the number of atoms of the same element on the right side. This is why we need to balance the chemical equations. Now we can look balancing of chemical equations. So we are trying the method hit and trial methods. Okay. The steps are simple. Step 1, write down the skeletal equation first. You have to write down the skeletal equation. Just write the chemical formula of all the reactants and product. So now the step 2, count the number of atoms of each element on both sides, the left side and the right side. Step 3, if they are not equal, start balancing. To balance, you can only add coefficients, that is numbers in front of the formula. You cannot change the subscripts, which are the small numbers written inside the formula. For example, you cannot change H2O to H2O4 or something like that. You cannot change the subscripts, but you can change the number in front of the formula. Okay, so that would changing the substance itself. If you are changing the subscripts, that means you are changing the substance itself, so which is wrong. You can change only the coefficients. Now step 4, after making all the changes, verify again by counting atoms of each element on both sides. Make sure they all match. And step 5, once balanced, all physical state symbols in brackets after each formula. That we will discuss in the later sessions. So there are 4 steps. First one is write the skeletal formula. Second step is count atoms of each element on both sides, LHS and RHS side. LHS means left hand side and RHS means right hand side of the equation. Then third step is balance elements with most atoms first and add coefficients. Don't change the subscript, you can change only the coefficients. Now the fourth step, verify atoms on LHS and RHS, and LHS must be equal to RHS. Okay. Then you have to add the physical state symbols. Means that if it is a solid, you have to write S in the bracket. If it is a liquid, you have to write L in the bracket. If it is a gas, you have to write G in the bracket. Or if it is an aqueous state, then you have to write AQ in the bracket. That we will see in the next upcoming session. So let me give you a worked example to make this very clear. Let us balance the reaction of iron with water. Skeletal equation is Fe plus H2O gives Fe3O4 plus H2. This is the skeletal equation. Let us count atoms on the left side. We have 1 iron, 2 hydrogen, 1 oxygen in the left side, and we have 3 iron, 4 oxygen and 2 hydrogen in the right hand side. So by looking at this number of atoms, we can say clearly that they are not balanced. So now let's try to balance this equation. Fe plus H2O gives Fe3O4 plus H2. So look at this equation. How many iron atoms are there in the left side? There is only 1 ion, Fe. But in the product side, in the right side, there is 3 iron atoms. And how many hydrogen atoms are in the left side? There are 2 hydrogen atoms, but in the right side, there are 2 hydrogen atoms. So hydrogen atom is balanced. But look at the oxygen atoms. How many oxygen atoms? 1 oxygen atom, but in the product side there are 4 oxygen atoms. So this equation is not balanced. This is just a skeletal equation. So now we have to balance. You can start from the iron. So there are 3 ions in the right side. So we have to give 3 in the left side also. So first we can write 3Fe in the LHS side. So we are writing 3Fe. Now in the RHS side, there are 3 Fe, so ion is balanced. Fe, the number of ion atoms are balanced. Okay, now we can move to the hydrogen atom. How many hydrogen atoms are in the left side? Number of hydrogen atoms in the left side and the right side is same, but look at the oxygen atoms. There are 4 oxygen atoms in the product side and only 1 oxygen atom in the reactant side. So we had to balance this oxygen atom. So we can look at this oxygen on the RHS. There are 4 oxygen. So we have to write 4H2O in the reactant side. So if you write 4H2O, then oxygen will be balanced, but the number of hydrogen atoms will change. If you write 4H2O in the left side, then there will be 8 hydrogen atoms in the LHS side, and still there is only 2 hydrogen atoms in the RHS side. So now you have to change the number of hydrogen atoms. So if you want to convert into 8 number of hydrogen atoms in the RHS side, you have to give 4H2. Means if you give 4 as coefficient for H2, then there will be totally 4 into 2, 8 number of hydrogen atoms. Got it? So basically we can say, what will be our equation now? 3Fe plus 4H2O plus Fe3O4 plus 4H2. So there are 3 ion atoms in the left side and right side also, and 4 oxygen atoms in the left and right side, and 8 hydrogen atoms in both sides. Okay, so this equation is balanced now. So now we converted this skeleton equation into balanced equation. This is how you have to balance the chemical equations. So the key rule that you have to know is that you can only add coefficients. Coefficients means numbers in front of formula. Never change subscripts inside the formula. If you change the subscript, it will completely change the compound. Now let us come to the main topic of this reaction, different types of chemical reactions. Types of chemical reactions. So there are totally 5 different types of chemical reactions. One is combination reaction, decomposition reaction, displacement reaction, double displacement reaction, then redox reactions. Okay, so first we can start with combination reactions. So what are combination reactions? They are the reactions in which 2 or more reactants combine to form a single product. There may be 2 or more than 2 reactants, but they will form only one single product. That is called combination reaction. Okay, so we can say the pattern of this reaction using the example general formula A plus B gives AB. There are 2 reactants A and B. They are converted into a single product AB. So this is called combination reaction. Okay, for example, calcium oxide CaO, which is reacting with the water molecule H2O, and it gives CaOH twice. So what does it mean? Calcium oxide on reaction with water molecule, it produces a single product, that is calcium hydroxide. And the calcium oxide is known as quicklime, and calcium hydroxide CaOH twice is known as slaked lime. And during this reaction, a large amount of heat is also produced. Okay, so this is an exothermic reaction. We will explain this term exothermic and endothermic later in this session, but now you can just get this point. Calcium oxide conversion to calcium hydroxide by treating with water molecule is an exothermic reaction. Now see the next example, burning of a coal. Okay, the reaction is carbon when reacted with the oxygen, it produces carbon dioxide. This is also a combination reaction because there is 2 reactants, it forms only a single product, that is carbon dioxide. Okay, now we can see one more example, formation of water. How water is formed? By reaction between hydrogen and oxygen to form H2O water molecule. The formula, chemical formula for water is H2O. So 2H2 plus O2 gives 2H2O. 2 hydrogen atoms react with 1 mole of oxygen atom and gives 2 water molecules. Okay, now we can move to the next reaction, that is decomposition reaction. So what is a decomposition reaction? It is a reaction in which a single reactant breaks down into 2 or more simpler products. What is decomposition reaction? A single reactant breaks down into 2 or more simple products. So this is just opposite of combination reaction. What was combination reaction? 2 or more reactants combines to form a single product. But in decomposition reaction, a single reactant breaks down into 2 or more simpler products. So these 2 reactions are opposite to each other. Now look at the pattern AB gives A plus B. The reactant was AB, which is a single reactant, and that breaks down into A and B. So this is a decomposition reaction. Now, for decomposition reactions to happen, they need some form of energy. So for example, if they want to break the AB, okay, they want some energy to break that bond in order to form the corresponding similar products. So based on the energy used for the decomposition reaction, there are different types of decomposition reactions. For example, we can see three different types of decomposition reaction: thermal decomposition reaction, photolytic decomposition reaction, then electrolytic decomposition reaction. So what is the difference between these three reactions? In thermal decomposition reaction, the energy used to break this reactant is thermal heat. But in photolytic decomposition reaction, the energy used is sunlight. In electrolytic decomposition reaction, the energy used is electric current. That is the difference between these three different types of decomposition reaction. The change is just in the form of energy. So we can say some examples. So firstly, for thermal decomposition reactions, calcium carbonate is undergoing decomposition to form the simpler products calcium oxide and carbon dioxide. So in this reaction, what is happening? A simple calcium carbonate CaCO3 is converted into CaO and CO2. AB converted into A plus B using the heat energy, using heat. So this is an example for thermal decomposition reaction. Now the second example for the photolytic decomposition reaction is that silver chloride 2AgCl is decomposing using the sunlight into 2Ag plus Cl2. Silver chloride is converted into silver and chlorine. This is a photolytic decomposition reaction because they are using the sunlight. Now the example for electrolytic decomposition reaction is a decomposition of water in presence of electric current. Water in presence of electric current, they are converted into H2 and O2. So the equation is 2H2O gives 2H2 plus O2. This is electrolytic decomposition reaction. So there are totally three types of decomposition reaction: thermal, photolytic and electrolytic decomposition reaction. In all these type of reaction, the energy form is just changing, but the general pattern is same. A single reactant is breaking down into two or more similar products. Okay. Now the third reaction is displacement reaction. What is displacement reaction? More reactive element displace a less reactive element from its compound. A more reactive element is displacing a less reactive element from its compound. The general pattern is that A plus BC gives AC plus BC. So what is this? So think of it like a stronger person taking place of a weaker person. Just that point you can connect with the chemical reactions. A classic example from your NCERT text is that an iron nail dipped in a copper sulfate solution. Iron is more reactive than copper. So iron pushes copper out of the copper sulfate solution. So the iron nail turns brown because copper is depositing on it, and the blue color of the copper sulfate solution slowly fades because copper is leaving the solution. So what happened here? There are two metals, iron and copper, but iron is the most reactive. Iron is the strongest one and copper is the weakest one. And copper is present in its copper sulfate solution. So iron can replace the strongest person can replace the weakest person. So iron can replace the copper. So the equation is Fe plus CuSO4 gives FeSO4 plus Cu. So here iron replaces the copper in the copper sulfate solution and produce the FeSO4 and releases the weakest person, copper. Okay, this type of reactions are known as displacement reactions. Now other examples also there. So zinc is reacting with the copper sulfate. Here comparing zinc and copper, zinc is the most reactive element. So it will release the copper from copper sulfate and form the product ZnSO4, zinc sulfate, and release the copper. So next example is Pb plus CuCl2 gives PbCl2 plus Cu. So here you can see Pb is more reactive than copper. So Pb can displace this copper from copper chloride and form the PbCl2 and release the copper. So basically we can say the strongest person is replacing the weakest person. So here you can see for this example, iron plus copper sulfate gives InSO4 FeSO4 plus copper. So in this example, iron nail turns brown because of the deposition of copper, and the blue color of the copper sulfate solution fades because of this process. Initially copper sulfate had a blue color, but because of this process it fades the color. Okay, that's about the displacement reaction. We will discuss the order of the reactivity of these metals later in this session. Okay, don't worry about that. Now we can move to the fourth reaction, that is double displacement reaction. In a double displacement reaction, what's happening? Two compounds exchange their ions with each other to form two new compounds. The pattern is AB plus CD gives AD plus CB. What is happening? Exchange of ions between two compounds, and they often forms a precipitate as a result of this displacement reaction. There is a double displacement that's happening here. So in this example, AB plus CD gives AD plus CB. AB, there are two ions, a cation and anion. In CD, there are two ions, cation and anion. So the cation of AB will react with the anion of CD, and the cation of CD will react with the anion of AB, and they form the corresponding products. And in the equations, you can note this point. In every equation, the first one will be cation and the second atom will be the anion. So here AB, A is the cation, B is the anion, and in CD, C is the cation and D is the anion. So you can say the cation of AB will combine with the anion of CD. So you will get AD and CB. So this is how double displacement reaction works. Now you can see one example. When sodium sulfate solution is mixed with barium chloride solution, sodium sulfate is Na2SO4, it is mixed with barium chloride solution, BaCl2, you will get BaSO4 and 2NaCl. So here they exchange their partners. So sodium goes with the chloride and barium goes with the sulfate. So barium sulfate is insoluble in water, so it forms a white precipitate and settle down. So the equation is Na2SO4 plus BaCl2 gives BaSO4 plus 2NaCl. So this arrow mark, this indicate the precipitate. So barium sulfate is a precipitate here. It has a white color. Now the next example is PbNO3 twice plus 2Ki. Okay. So here what will they form? PbI2, which is a precipitate, and along with that they will produce KNO3 also. This lead iodide PbI2 has a yellow color. So this precipitate has a yellow color. So basically we can say white precipitate of BaSO4 formation and yellow precipitate formation of lead iodide. These two reactions are double displacement reaction. They are exchanging their ions between the compounds. Okay. Now we can move to simple but powerful concept, exothermic and endothermic reactions. We can say every chemical reaction either releases energy or absorbs energy. So an exothermic reaction is one where energy, usually in the form of heat, is released during the reaction. They release heat during the reaction. So the surrounding becomes warmer because of the heat releasing, the surroundings become the warmer. So you can think it like exit. So heat is exiting from the system, means it is going out. Example of exothermic reactions are burning of natural gas. So during this burning, it releases heat. So natural gases during burning, what it will happen? It will release the heat. So methane plus 2O2 CH4 plus 2O2 gives CO2 plus 2H2O. So here it is releasing the heat. So this reaction is an exothermic reaction. Another example you can see the quicklime formation. This example we had seen when we learned about the combination reactions, formation of slaked lime. So here it is releasing the heat so that it is an exothermic reaction. Then respiration. Respiration is a type of exothermic reaction. What's happening here during the respiration in our body, where glucose reacts with oxygen to give carbon dioxide and water and energy. So this is a formula for glucose. C6H12O6 reacts with the oxygen and form carbon dioxide and water plus energy. So there is a form of energy released during this reaction. So this is an exothermic reaction. Then we can see some other examples. Combustion of LPG, coal and petrol. They are also exothermic reaction. Then decomposition of vegetable matter to form the compost. So this is also an exothermic reaction. Now we can look at the endothermic reaction. What is endothermic reaction? Just opposite to exothermic reaction. Energy is absorbed during the reaction. So the surrounding becomes cooler because it is absorbing heat from the surrounding, and so that the surroundings become cooler. So think of the word endo. Endo means enter. So heat is entering the system, being taken in. So it is taking the heat from the surrounding. So endo means taking of the heat. Examples of endothermic reaction is photosynthesis in plants. So where carbon dioxide and water absorbs sunlight energy. So they absorb sunlight energy to form the glucose and oxygen. So this reaction is an endothermic reaction because they are absorbing a form of energy. Okay. Next example is calcium carbonate decomposed to form calcium oxide and carbon dioxide. This is a thermal decomposition reaction where it releases heat. Calcium carbonate converted into calcium oxide and carbon dioxide. This is a thermal decomposition reaction. What is happening here? It absorbs heat and forms the product CaO, and carbon dioxide means it is absorbing the heat and producing the products. So this is an example for decomposition, thermal decomposition reaction that we have already learned. And another example is electrolysis of water, means they are using electric current for decomposition and form the product H2 plus O2. Then the photolytic decomposition reactions, 2AgCl gives 2Ag plus Cl2. They are using sunlight. We have discussed this one, right? So this reaction, this is used in photography also. So you can remember this reaction. This is an example for photolytic decomposition reaction. So another day-to-day life example is evaporation of water or melting of ice. In all this process, they are absorbing heat. If the ice is want to melt, it needs to get heat energy. It absorbs heat from the surrounding and it gets melted. So that's how this endothermic reaction is happening. The same thing is happening in evaporation of water also. Water is absorbing heat and converted into steam. Okay, this is about the endothermic and exothermic reaction. So we can say exo means heat is exiting from the system. So heat leaves the system, feel warm for the surrounding, and endo means heat enters to the system. So heat absorbed from surrounding, which means the surrounding becomes cold. Okay, now let us go to a bit deeper into displacement reactions and also talk about the precipitation reactions. Okay, so displacement reactions, we had told that in displacement reaction the stronger person is replacing the weaker person. So you already know that in displacement reaction a more reactive element displaces a less reactive element. So let us revisit the activity with an iron nail in copper sulfate solution, because it is very important for your exam. When you take a clean iron nail and dip it in the blue copper sulfate solution, you observe two things happening. The iron nail slowly turns brownish because copper is being deposited on it, and the blue color of the solution slowly fades and becomes greenish because iron is now dissolving into the solution as iron sulfate. This is because iron is more reactive than copper in the reactivity series. So iron displaces copper from copper sulfate. The equation is Fe plus copper sulfate, which is in aqueous format, and gives FeSO4 plus copper, which is in solid format. So here Fe is more reactive, so it displaces copper from the copper sulfate solution and release the copper, and iron takes the place of the copper, so it forms FeSO4. So what is the observations of this reaction? Iron nail turns brownish because of the deposition of copper, and the blue color of the copper solution that fades and it becomes somewhat greenish type of color. Okay, so this is a displacement reaction that we already discussed. Now we are going to look at the reactivity series of this. This is the reactivity series. In this series, the more reactive metals displace the less reactive metals. So more reactive metals are from this side and it goes to the less reactive sides. So elements to the left can displace the element to the right from their salt solution. So for example, you can take magnesium and aluminium. So aluminium is in its salt solution, magnesium is there, then magnesium can displace the aluminium from that solution. But the opposite cannot happen. If the magnesium in its salt solution and aluminium is there as a metal, then aluminium cannot displace the magnesium from its salt solution. Why? Because magnesium is high reactive than aluminium, so it cannot happen in opposite side. But what can do, elements to the left of this series can displace element to the right of this series from its salt solution. So that is reactivity series. So it's very important because you have to learn this pattern: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, copper, silver, gold. So these are the important metals that you need to know about your exams. So don't skip these elements, don't skip this part. Okay, that's about the reactivity series of displacement reaction. Now precipitation reactions. So they are actually a special type of double displacement reaction. In this reaction, when two aqueous solutions are mixed, one of the product formed is an insoluble solid that separates out from the solution. So this is called a precipitate. During this precipitate reaction, one is not soluble in the solution, so it get precipitated. So this insoluble precipitate is known as the precipitate, and that is indicated using a arrow, down arrow. The symbol used for a precipitation equation is downward arrow after the formula. For example, sodium sulfate reacts with the barium chloride and forms the barium sulfate here and sodium chloride. Here barium sulfate is the precipitate and it is represented using this downward arrow. So this is about the precipitation reaction. So now we covered different types of reactions. Which are the different types of reactions? Combination reaction, the two reactants combine to form a single product. In decomposition reaction, a single reactant breaks down into two or more similar products. That is just opposite of combination reaction. And in displacement reaction, what is happening? More reactive element displace the less reactive element, and you have to know about the reactivity series that we discussed now. Then the double displacement reaction, the exchange of ions between two compounds happen and they can form a precipitate that is represented using the downward arrow. And we discussed about exothermic and endothermic reaction. Exo means release of energy and endo means gain of energy. Okay, now we can go to the next term, oxidation and reduction reactions. So oxidation and reduction always occur together. When one substance is oxidized, another substance is simultaneously reduced. So let us first understand what is oxidation and reduction, then we can go to the details. So you can just understand this oxidation and reduction, these two reactions happens in together, and they together known as redox reaction. So basically we can say redox reaction is a chemical reaction in which oxidation and reductions happens together. Okay, now we can discuss what is oxidation and what is reduction. Oxidation means a substance gains oxygen. Means that to a substance, if we are adding oxygen and it produces a product with the added oxygen, or it has an hydrogen atom and it is losing the hydrogen atom from that compound in the product, then that's also an oxidation reaction. Basically we can say if gain of oxygen and loss of hydrogen is happening in the reaction, then such kind of reaction is known as oxidation reaction, and the substance is called oxidizing agent. So gain of oxygen, loss of hydrogen, that is known as oxidation. Simply you can remember like this: oxidation, ox for oxygen, ation for addition. So oxidation means addition of oxygen, then removal of hydrogen, just opposite of addition of, if it is addition of oxygen, then just opposite of hydrogen, removal of oxygen, or gain of oxygen and loss of hydrogen. These two terms you can use, either you can use the terms gain or loss, or you can use addition and removal. So simply you can get oxidation means addition of oxygen and removal of hydrogen, and the substance which undergo this oxidation reaction is known as oxidizing agent. Now look at this example: 2Cu plus O2 gives 2CuO. So here oxygen is added to the copper, so that what happened? Copper is oxidized. So here copper is oxidized to copper oxide because addition of oxygen is happening. So how can you get this? Look at the reactant and the product. In the reactant there is no oxygen atom, but in the product there is one oxygen atom. So you can simply understand oxygen is added to the copper metal. So you can say addition of oxygen. So there is addition of oxygen, that means it is an oxidation reaction. Now reduction reaction just opposite of oxidation. In oxidation, gain of oxygen, then in reduction it is loss of oxygen. In oxidation it is loss of hydrogen, in the reduction reaction it is gain of hydrogen, and the substance which undergo this process is known as reducing agent. So for example, it is CuO, we are adding hydrogen. This is addition of hydrogen, right? And copper is removing its oxygen also. So we can explain this in two terms. Either you can say copper oxide is converted into copper. So here in the reactant it was copper oxide, but in the product it is copper only. So in the reactant there were oxygen atom, but in the product there is no oxygen atom. So that means copper oxide is converted into copper. That is an oxidation reaction. At the same time, addition of hydrogen to reactant CuO, or hydrogen is added. So we can say addition of hydrogen, and this reaction is reduction. Now here is the best memory trick in all of chemistry. So remember the phrase oil rig. Either you can remember like this, or as I told earlier, oxidation means addition of oxygen, and the rest of the things you can just derive from this term. So, or you can use this memory trick, oil rig means that it stands for oxidation is loss and reduction is gain. So oxidation is loss, means loss of electrons, loss of hydrogen. Reduction is gain, gain of electrons or gain of hydrogen, or loss of oxygen, just opposite to that. Okay, so now we got what is oxidation and what is reduction, and we know that the reaction in which both oxidation and reduction happens together, such kind of reaction is known as redox reaction. And now we can see one example for that. So copper oxide plus H2 gives copper plus H2O. In this reaction, what is happening? Copper oxide is reacting with H2 and forms copper plus H2O. So here CuO is having an oxygen atom, but in the product there is no oxygen with the copper. So means there is a removal of oxygen or loss of oxygen. So if loss of oxygen, that is reduction reaction, right? So this conversion CuO to Cu, this is a reduction reaction. Okay, so copper oxide is reduced to copper. Now H2 is converted into H2O. There is addition of oxygen. Initially it was H2, but in the product there is H2O. There is addition of oxygen or gain of oxygen. So gain of oxygen, it is oxidation. So we can say H2 is oxidized to H2O. So I hope you got this oxidation and reduction. How can you separate the oxidation reaction and reduction reaction? Now we can look oxidizing agent and reducing agent. So here copper is reduced to copper using H2. See, H2 is reducing copper oxide into copper. So here H2 is a reducing agent. Got it? H2 is a reducing agent. At the same time, copper oxide is oxidizing H2 into H2O. So copper oxide is oxidizing agent. So did you get how can we calculate oxidizing agent and reducing agent? If reduction is happening to that reactant, then that is oxidizing agent. If oxidation is happening to that reactant, then that is a reducing agent. Got it? Finally, we can say copper oxide, there is loss of oxygen to becomes copper, so it is reduced, and so that it is an oxidizing agent. At the same time, hydrogen gains oxygen and becomes H2O, so it is oxidized, and that is an reducing agent. We can see some more examples here. Zinc oxide plus carbon gives zinc plus carbon monoxide. Here carbon is oxidized to carbon monoxide. There is addition of oxygen, so it is oxidation reaction, so that it is an reducing agent. At the same time, zinc oxide is converted into zinc. There is removal of oxygen, so that it is reduced. Zinc oxide is reduced to zinc. At the same time, this is an oxidizing agent. So another example, Fe2O3 plus 2Al gives Al2O3 plus 2Fe. So this is a thermite reaction. Here aluminum is oxidized and Fe2O3 is reduced, and we can calculate the oxidizing and reducing agent here. Aluminum is the reducing agent and Fe2O3 is the oxidizing agent because it is oxidizing aluminum to Al2O3. Next example is MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. Here HCl is oxidized and MnO2 is reduced. Okay, this is about the oxidation and reducing agents and redox reaction. Now we can move to the next topic, important topic, that is corrosion and rancidity. This is the last topic of this chapter, so which is corrosion and rancidity. Both of these are real life effects of oxidation that are harmful and undesirable. So let's see. Corrosion is when a metal is slowly attacked or damaged by substance in its surrounding like moisture, acids and oxygen. For example, when iron is interacting with moisture, if it is placed in a humid atmosphere, after few days or few months, it will get a reddish brown precipitate on it. That is called rusting of iron, and this process is called corrosion. So basically, what is corrosion? When a metal is attacked by substance around it, such as moisture, acid, it gets damaged. So it is a slow oxidation process, and this slow oxidation process is known as corrosion. So examples: iron converted into reddish brown rust, the black coating on the silver. So this is why silver jewelry turns black over time. So whenever we use multiple times, you can see that the silver, that color is changed in blackish color. So that is because of this slow oxidation process that happening here. So that's also an example for the corrosion. Then green layer of the copper on the copper metals, it forms a green color after a long time. So this is also example for corrosion. Now the question is, how do we prevent corrosion? Can we prevent this corrosion or not? So answer is yes, we can prevent the corrosion. So there are several methods. Painting or oiling or greasing the metal surface prevents it from coming in contact with the moisture and oxygen. That is one method. Or galvanizing, that is another method. So galvanizing is a method where iron is coated with a thin layer of zinc. Zinc is more reactive than iron, so zinc gets corroded instead of iron, so thus protecting it. Okay, so that is next method, galvanizing. Then another method is making alloys. So like stainless steel, which is a mixture of iron, carbon, chromium. So it prevents corrosion because chromium forms a protective layer. Okay, so that's another method. The next last method, we can say electroplating with metals like chromium or tin also protect iron from corrosion. So these are some prevention methods. This is how we can prevent the corrosion. Okay, now rancidity. Rancidity is oxidation of fats and oil present in food, which changes their smell and taste. So rancid food is unfit for consumption. So what does it mean by rancidity? What is happening here? Oxidation of fats and oil which present in the food. So when fats and oil in food are exposed to oxygen over time, and their smell and taste changes, making the food unfit and unpleasant to eat, there will be a foul smell. So you must have noticed that old chips or biscuits or butter smell bad after some time, right? So that is rancidity. So it happens faster in open air, heat, and in the presence of moisture and light. So because of that, it will smell bad or taste bad. Okay, so this is because of the oxidation process that happens. That is known as rancidity. So how can we prevent this rancidity? We can add antioxidants to food. Antioxidants are substances that prevent oxidation. Antioxidant, oxidant prevention. They are preventing oxidation. Okay, so we can add antioxidants to food. Antioxidants are substances that prevent oxidation. So common antioxidants include BHA, BHT and vitamin E. These are some common examples for the antioxidants. So other method is that we can also store food in airtight container so that oxygen cannot reach the food. So that is another method. So chips packets, you can see the chips packets, snacks packets are often flushed with nitrogen gas before sealing, because nitrogen is an inert gas and does not react with the food. So this prevents oxidation. Okay, that's another method. The third method we can say refrigeration, meaning that keep at the low temperature. So it is a powerful and helpful because low temperature slows down the rate of oxidation. Okay, that's another method. And the last and final easy method is keep away from direct sunlight. So if you are just keeping your food away from direct sunlight, it prevents rancidity because light speed up the oxidation reactions. If you just keep it out of sunlight, so it slows the oxidation process. So you can prevent the rancidity. So one very important exam point to remember is that both corrosion and rancidity are undesirable effects of oxidation in everyday life. Now Let us also quickly go through the physical state symbols and reaction condition symbols used in chemical equations. So here you can see for solid substance we will represent S, for liquid L, for gas G, for aqueous solutions AQ. I have given some examples over here. Then we can see for some symbols for reaction conditions. You can see an upward arrow here. Upward arrow is indicating that a gas is being evolved or released. And the downward arrow we have already discussed. Its formula means a precipitate is being formed. Upward means something is evolved, a gas is evolved. Here you can see it is heat is evolved, and the downward arrow means precipitate is formed. Okay. If sunlight is used, so basically you can say you will write sunlight on the top of this reaction, and if it is there, then you can confirm that reaction it's using sunlight. An electrolytic reaction, it will write electric current on it if the electric current is used. Then for catalyst usage, catalyst is something, a compound which speed up the chemical reactions. So the catalyst name will be written on the top of the arrow mark. So these are the some simple terms, and basically there are some other symbols also, but we are not going to discuss into deep. You can just try to understand these terms. If upward arrow, that means something in gas is evolved. A downward arrow means something is precipitated. And sunlight, electric current, and catalyst. So now we can just summarize whatever we have learned in this chapter up to now. So we have learned different terms, right? Combination, decomposition, displacement, displacement, a lot of terms. So we can just summarize all these points here. Okay. So the chapter is chemical reactions and equations. Okay, this is our chapter name. What are there in this chapter? There are totally 5 important chemical reactions: combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and redox reaction. Redox reaction is oxidation plus reduction, that is commonly known as redox reaction. So these are the 5 important reactions in this chapter. Now we can go through these topics. Combination reaction. What is combination reactions? 2 or more reactants combines to form a single product. For example, calcium oxide plus H2O combines to form calcium hydroxide. This is a combination reaction. And decomposition reaction. Decomposition reaction is just opposite to combination reaction. So in combination reactions, there 2 or more reactants combine to form product, but in decomposition reaction, one reactant decomposes to form 2 or more products. So the important term is single reactant is converted into 2 or more products. And here for this reaction, decomposition reaction, it always needs some energy to break this bond. So based on the energy used, we can have different types of decomposition reactions: thermal decomposition, photolytic decomposition, electrolytic decomposition. So if it is using the thermal energy, heat energy, then it is thermal decomposition. If it is using sunlight, then it is known as photolytic decomposition reaction. If it is using electric current, then it is known as electrolytic decomposition reaction. And for example, generally we can say decomposition reaction, CaCO3 is converted into CaO and carbon dioxide. This is an example for decomposition reaction. Now displacement reaction. Here more reactive metal is displacing the less reactive one from its solution state. For example, iron plus copper sulfate gives FeSO4 plus copper. So here Fe is the more reactive than copper. So Fe can replace copper in the copper sulfate solution and release the copper and forms FeSO4. So we have discussed these topics also. One important point that we have to notice is reactivity series. So in the reactivity series, the metals with the high reactivity will replace the metals with low reactivity. The metals in the left side will displace the metals in the right side. Okay, then double displacement reaction. In double displacement reaction, ion exchange is happening. So the reactants are exchanging their ions to each other, and often they produce a precipitate which is insoluble in solvent. For example, Na2SO4 plus BaCl2 gives BaSO4 plus 2NaCl. Here Na2SO4 and BaCl2, they are exchanging their ions each other and produce NaCl and BaSO4. Here BaSO4 is the precipitate. The precipitate is indicated using this downward arrow. Now the next reaction, redox reaction, which is combination of oxidation and reduction, means that redox reaction is a chemical reaction in which oxidation and reduction happens together. What is oxidation? Oxidation is either gain of oxygen or loss of hydrogen. For example, in 2Cu plus O2, copper is adding oxygen to that. So you can compare the reactant and product. In reactant there is no oxygen atom with the copper, but in product there is oxygen atom with the copper. That means oxygen is added to copper. So there is a oxidation reaction. But in this reaction, reduction reaction, what is reduction? Loss of O2 or gain of H2. Means that for example, copper oxide plus H2 gives copper plus H2O. Here we are adding hydrogen, and or we can say removal of oxygen, CuO to Cu. This conversion, here there was oxygen with copper, but it loses that oxygen and form copper. So that is reduction reaction. And in a reaction, oxidation and reduction both happens together, that is redox reaction. Now exothermic and endothermic. What is exothermic? Heat released. If in a reaction, during the reaction, heat is released, then that reaction is exothermic reaction. For example, in this reaction CH4 plus 2O2, CO2 plus 2H2O, during this reaction, heat is released. So that reaction is exothermic. Then endothermic reaction. Endothermic means heat absorbed. If during a reaction, if it is absorbing heat, then that reaction is known as endothermic reaction. For example, during calcium carbonate conversion to calcium oxide and CO2 carbon dioxide, this is a decomposition reaction that we have learned in this decomposition part. During this reaction, heat is released. So this reaction is known as endothermic reaction. If heat is released, then the reaction is known as endothermic reaction. Then the last two terms, corrosion and rancidity. What is corrosion? Corrosion is slow oxidation of metals by environment and which causes the damage to the metal. So that process, that reaction is known as corrosion. And example, rusting of iron means reddish brown color formed on the iron due to the interaction with the moisture when we keep it in humid places. Then rancidity is oxidation of fats or oils in food which spoil the food, which damage the food so that we cannot further use that food items. For example, in the chips and snacks items, you can say sometimes it has a foul smell, it has a bad smell, so that you cannot take that food item. So that's as a result of the oxidation of the fats or oils in that food item, and that is known as rancidity. So we have discussed all the reactions and terms used in this chapter. So I hope you got all these points. So finally we can say there are 5 major types of reactions CDDR. So what is this? C for combination, decomposition, displacement, double displacement and redox reaction. These are the 5 important types of chemical reactions that we have discussed now. So I hope you got all these points. We have discussed all the important terms in this chapter. So if you have any doubts, just comment below or reach out to me. Thank you for watching and see you in the next video.